Here's the answer key for the Chapter 10 retake practice packet I gave you. Number 1, x to the square root of 6 to the square root of 24. You have a power to a power, you multiply. Simplify the square root of 24 to be the square root of 4 times the square root of 6, which is actually 2 square roots of 6. When multiplying radicals, only the index has to be the same, so you can multiply the radicands. So that's 2 times the square root of 36. Square root of 36 is 6, so it's 2 times 6, which is 12, so you get x to the 12th. Number 2, base 5 raised to the negative 2 equals 1 over 25. Write that in log form. Well, I have base 5 of 125 is negative 2. Alright. Number 3, log 10. Loop, swoop, so 10 to the third equals 1,000. Number 4, evaluate. You got to put it set equal to some variable. I chose x, and then I loop, swoop. 16 to the x equals 4. Then I got like bases. 2 to the 4th is the same as 16, and 4 is actually 2 squared. So I get 2 to the 4x equals 2 squared. Set the exponents to each other and get x equals 1/2. Number 5, change 9 to be 3 squared. And then set your exponents equal to each other. You end up getting r equals 1. Number 6, 16 is 4 squared, so I get 7a equals 10a minus 12, end up getting a equals 3. Number 7, I have to remember that 1/27 can be written as 27 to the negative 1, and then get like bases. Change 9 to be 3 squared, change 27 to be 3 cubed. End up getting x equals 5/2. Number 8, loop, swoop, so x to the negative 2 equals 1 over 49. Well, 1 over 49 is the same as 49 to the negative first. Then change the base to be 7 squared. So if I get x to the negative 2 equals 7 to the negative 2, the only way that's true is if x is equal to 7. Number 9, loop and swoop, 6 squared equals x equals 36. Number 10, if I have log 8 of something equal to log 8 of something, that must mean that the guts are equal to each other, so I just set 9x minus 5 equal to 3x plus 49 and get x equals 9. On the back, remember your rules. So log 7 of 36 minus log 7 of x. That means I can divide. I can combine those into one log and combine them using division. So that's 36 over x equals 4. And you end up getting x equals 9. Number 2 on the back, they're both log 3s, so I can set them equal to each other. 3x plus 10 equals x squared. Well, that's a quadratic, so I want it set equal to 0. So move everything over, set it equal to 0, factor it, and then set both factors equal to 0 and get negative 2 and 5. Number 3, okay, this is where we can roll the coefficient onto the log. So I have log base 3 of 25 to the 1/2 and log base 3 of 2 to the 5th. So, and those are being subtracted, so I can combine them using division. I get x equals 25 to the 1/2, which is the square root of 25, which is 5, over 2 to the 5th, which is 32. So x equals 5 over 32. Number 4 we couldn't do. Number 5, I don't know if we're going to see that on the test, but that was the change of base formula. We kind of touched on that in the notes. So you just take log base, you just change the bases to base 10. So it's log base 10 of 760 is over log base 10 of 9, and you get that. Number 6, the only way we can solve for a variable that exists in the exponent is to log both sides. So log both sides, then I can roll the exponent out front, divide both sides by log 6, I get 1.2851. Number 7, I have e, so that means that tells me I have to natural log. Then I can roll the exponent out front. Natural log of e is 1, so you end up getting natural log of 6 equals 4k. Divide by 4, you get that. Same thing for number 8, natural log both sides. Divide by 0.05 and you get 117. On the back, number 1, I thought the equation was wrong. It should be PE to the RT. So you get your initial value was 1050, so that's your starting value, and then E raised to the 7.02% as a decimal, so move that decimal over 2 places, so it's 0.0702. R is that, and then T is 2 years. So just plug that into your calculator. Same thing for number 2. You invest 1,000, E to the 0.07, and then T was 2 years. That's what you get. Number 3. This is just a different kind of equation, but same deal. It's 125,000 is the initial value, and then 1 plus R, which is 0.08, raised to the N, which is 8 years, and you end up getting $231,000 and $366.28. Number 4, she wants to give her, so she wants to end with 3,000. She invests 1,000. You can't natural log both sides until E is by itself. So first divide both sides by 1,000. So you get 3 equals E to the 0.1t. Natural log both sides, get rid of the E, and just get ln of 3 divided by 0.1, and you get 10.9861 years. And finally, number 5. So we're going to solve for t, so it gets down to 15,000. It started at 60,000, and we use this formula there. That was a typo. That's the formula for growth, and this is decay, so that's got to be minus. So 1 minus 0.2 to the n, which is, again, you have to get rid of the coefficient, so divide both sides by 60,000. You get 0.25 equals 0.8 to the n, and then natural log both sides, and get n alone by dividing by natural log of 0.8, and you get 6.2126 years.